Okay. Alright, Isaac. Thank you so much for being willing to be interviewed.
Yeah, absolutely.
But yeah, so we'll just go on with the interview. And I have a couple of questions. So I just have some couple general questions to ask. So the first question is, what first got you interested in embedded systems programming?
Yeah, that's a good question. I think the first thing was probably just like playing around with an Arduino. I had a robotics class, and a lot of the time, like my other teammates work on other projects. There's an option to do like an Arduino project though each time, and I usually pick that one. And so it was really cool, like dealing like with like hardware and like seeing like software actually like move, or like be able to like move physical things. Like you're using just like coding to be able to like manipulate the world around you, which I thought was a super cool concept. So I think just that is kind of what sparked me to do it, just to kind of get into it. And I also realized that like AI, it's been kind of crazy. And like, I don't know if our, software development will totally get replaced, but, AI does not have hands yet, So like, is a little protected against like, if AI is going to like start taking jobs eventually, So yeah, just kind of for the hardware aspect of it and just like enjoying, like that my code is like physically changing things, I think it's kind of cool. So yeah.
Okay. No, that's interesting. And would you say that when you got interested in embedded systems programming, would you say that it's more like of an influence from your friends or more of an influence from just like the internet?
I think it's probably kind of I'd say more of like the internet. Yeah, I'd say it's definitely from personal experience. Like my classes, I think was one of the biggest things that kind of got me interested in it. Even like my first semester, I took some Arduino stuff, which I thought was really cool. But overall, definitely more the internet. I did a lot of research on embedded systems, and just to kind of understand like what positions are open and like salaries and like what kind of requirements you need or to be able to get a job in embedded systems. So yeah, definitely a little bit more on the internet side. I do have a few friends. I did have one buddy actually who told me that I should switch to computer engineering. It was actually a long time ago, yeah, like first semester. And I guess after when I started getting into it, I was like, his words kind of were echoing my mind. Like, I'm like, yeah, maybe so. But mostly the internet, I'd say, yeah.
Okay, no, that makes sense. No, I feel the same way. I feel like with a lot of just the way or the trajectory that I would want my career to go into right now, it's more influenced by the classes that I've taken, as opposed to just like the people around me. Yeah, and so the follow-up question that I have for you is, what kind of projects have you worked on that had involved embedded systems programming?
Yeah, I think one of the first ones that I dealt with was kind of like a weather station type of thing. And so it was a project where I had all these like little different sensors, like humidity and like the temperature, and just like some other little, I can't remember all of the things were, but a little light sensor too or something like that. And that was kind of the first project that kind of like sparked my interest in it, and since then I've just kind of played around with some other things. I think like especially this last summer I was experimenting with this one particular type of microcontroller. Can't remember what it was called exactly, but it was like STM32, something like that. Yeah. And yeah, I kind of learned a lot more about that, and gotten to see a little bit better and understood it a little better. And yeah, maybe I'll ask me about that in a bit here. But yeah, that was just kind of some of the biggest projects or the most interesting ones that got me excited about it. So.
Okay, that's fun. And you're a computer science major, right?
I am, yeah.
Okay. Awesome. So how do you see embedded systems fitting into the broader field of computer science? How does it fit into computer science?
Yeah, that's a really good question. I came into software or computer science kind of thinking about like software development, but I realized that there's a lot more to like computer science is actually a very broad category, and embedded systems is kind of this interesting spot between like software and hardware, and then you have like for example, someone's like designing a drone, like you'd have people writing software, and then you'd also have like maybe electricians figuring out like designing the circuit boards and all that, and embedded systems is kind of more in the middle where you're working kind of both with hardware and software, It might be like creating like the firmware for the drone. But yeah, it's this very interesting kind of spot in the middle. I think it's helpful because you can kind of communicate with both sides, you know, like hardware, people that specialize in hardware and software, and I don't know, kind of like this bridge at least, and that's kind of how I see embedded systems, so.
Okay, well, that makes sense. I think that's one of, so before I came here to BYU, Idaho, I was really into just more the hardware side of things, so more just mechanical engineering. So instead of focusing on the software side of just creating like machines or just creating programs, or not programs, sorry, just like creating devices, I really like just focusing on like the hardware aspect of it. But once I got into a little bit in school, particularly with just programming in general, I think the first programming language I learned was Python. I saw that was a better fit in my opinion. But what you said just makes sense. Like, I feel like with embedded systems, you don't have to pick one side or one or the other. You can just do both. So I think that's also partly why I feel like I'm also interested in that, because I just want to do both.
Yeah, no, that's true. You can literally just combine interests and pick two things at once. So.
No, thank you so much for that. But those are some of the introductory questions that I have for you. But right now we will move on to more just career-oriented questions. And I know you're still a student, but I just have some questions here about embedded systems and how it would work, like how it would look like when you're actually like working as a professional in that field. So the first question I have is, what programming languages are most commonly used in embedded systems? And this can be like based off of like what you know already. So in your opinion, what is the most common?
Yeah, I think definitely like C is kind of one of the biggest ones. It's kind of the standard, you know, for it's been like a long time, you know. It's like, I can't remember how old the language is. It's like 50 years or something, you know. It's like super old language. I think so. Yeah, I can't remember the exact statistic, but like it's a very old programming language, but it's still very useful in embedded systems. Especially because it allows you to kind of manipulate the amount of storage you have. Or, for example, like in embedded systems, like you're working with very like small devices, you know, like they don't have very much memory. And so C is really cool because it lets you like allocate like, you know, like and like or manipulate like individual bits, you know. So you're like, I have like, okay, like 300, you know, like kilobytes or something. Well, that's a lot, but like, you know, like you are able to like control exactly where you want memory, and like variables, you know, you can also like choose when they're erased and like choose where to put them in memory, and so it's very helpful for that, you know, for that sort of thing. But then like Arduino type of thing, you know, that's like a little bit different than usually you use like C++, you know, for that sort of thing. But for most microcontroller stuff, you're usually using C as far as I'm aware. So
C.
Yeah.
Okay. I've heard of C before, but I don't really know much about it. How does it compare to C#, or how does it compare to Python, for example?
Yeah, that's a good question. Yeah, C is very it's interesting. It gives you a lot of control, you know, a lot of control over kind of every aspect of the program, you know, because you're doing a lot of things manually. At the same time, that kind of makes it a bit tedious, you know, because like you have to deal with pointers, for example. And like in most programming languages like C# or Python, it usually takes care of those for you. Like you never even look at pointers in the background and stuff, you know. But in C, you are literally like specifying where pointers are. And the dangerous thing is that you can like totally script your program, you know. Like in C# it's kind of like a safety, like in Python have like kind of safety guards against it. But if you do use them, you can use them to your advantage, and you can use them to be like, you know, it's a very powerful sort of thing. I'd say it's definitely a little more tedious. It has kind of some fewer things like built into it, you know, like, you know, since it's kind of an older language, but it definitely allows you to have more control over everything that's going on in your program and in the CPU, and it's like a lower level type of thing. So
interesting.
Yeah.
Oh, okay. So it gives you a lot of control. So it's more. Would you say it's more customizable, or?
Yeah, you could say that. Yeah, like I think one of the biggest things that kind of I was talking about earlier is like with like variables. You know, you're like you choose when to create and like erase variables, and that lets you like take advantage of all the room or this very small amount of space that you have on like embedded systems. It lets you, I guess add and delete variables whenever you need. So I guess you could say in a way it's customizable. It's more manual, I guess, is kind of in my mind.
Okay.
But it being manual can also be helpful. Like kind of like a car, sometimes you can have an advantage if you have like a stick shift versus an automatic car. So yeah.
Awesome. Yeah, that's actually really interesting. I don't know how to write C. I'll just be honest.
No, that's
So no, that's really interesting. I didn't know that you had to like mess around with pointers specifically.
yeah, it get confusing. You have like the asterisk and the ampersand and like this arrow. Yeah, it's a little it's a little weird to wrap your head around, but like when you get it, yeah, it's pretty powerful. So.
No, that's really interesting. Thank you for that.
Mm-hmm.
But the follow-up question is, so what are some unique challenges that you've seen, or at least in your experience, that you've seen with embedded systems? And when you take these unique challenges and compare them to the challenges that you would have with like just general software development, how does it compare?
Oh yeah, that's a good question. I guess one like very physical challenge is the fact that you're dealing with physical things too. So with software, it's usually like you find errors a lot of the time, and like you're not concerned about the hardware. You're finding like bugs in your code and stuff. And with embedded systems, it's like not only are you having bugs in your code, you're having physical bugs too. You know what I mean? It's like if there's like a bit of software or like a piece of hardware that's like not working right, or like a little connection that's wrong. It's like a tiny little a lot of different. I think it opens up more room for error, in a way, just because you're dealing with the physical and with the software type of stuff. But that being said, I think it's kind of cool. It's cool that you can physically debug stuff as well as like on a computer as well. So I think for me that's been one of the bigger challenges, and also just working at a lower level. You do have to when you're programming your computer, you almost never have to worry about how much storage you have. You can just like make like as many variables as you want, and you don't have to worry about them getting erased. And a lot of languages have like garbage collection that get rid of them anyway. But with C, it's like and with embedded systems, you are more concerned about how much space you have, how efficiently you're doing things. I guess efficiency is also in software, but yeah, no, definitely, it's like a little bit. You have some different things you have to kind of worry about, whereas in most cases in software development, you don't have to worry about it as much. So, yeah.
No, that makes a lot of sense. Have you ever built a computer before?
Ooh, that's a good question. I've never actually built a computer.
Uh-huh.
I did. I think it was my third semester. I read this book though called "But How Do It Know," and it was just kind of like my curiosity of how a computer like really works. Because people would always say things like the computer does like it thinks this and it does this. And like we're ascribing these like human characteristics to it, and like it still like makes it like shrouded in mystery, So I ended up reading this book that like starts from like the very start, like from binary up until like every like part of the CPU works, and for and so at that point I had a good understanding of exactly how computers work, which was really cool. I never actually made one totally from scratch. In Minecraft, I've done some redstone stuff. I did some cool logic gate circuits and stuff, and just like I even tried to make it like an ALU, like in Minecraft to do like math and stuff. So I did play around with that, but physically I've not actually created one. But I have studied quite a bit about how CPUs work, and it's pretty cool. So.
Okay, no, that's interesting how you brought up Minecraft. I'm not sure you've seen that one video, but it's I forgot the name of the channel, but it's on YouTube. This guy, he like built Minecraft on Minecraft, so you can play Minecraft.
Yeah,
on Minecraft.
I've actually seen that same video.
Yeah, it's
crazy. Yeah, and I saw one recently too, where someone like supposedly like they created an actual like large language learning model like in Minecraft, and it took like an hour for a prompt to work. It's like all that stuff. Yeah, but it's crazy. Like people are doing some pretty wild things, and yeah, Minecraft's cool. Like you can definitely deal with like little circuits and stuff, and because of redstone is just binary logic, and that's all computers are too. So.
Sense, yeah. Mm-hmm. No, if you think about it, that's what computers are like on like the most just basic level.
Yeah.
Binaries.
It's literally just like little wires turning on and off. That's it.
But no, the reason I brought up computers is because I have I built my first computer when I was 12 years old.
Oh, cool.
And I think the challenges that you had described earlier about how when it comes to embedded systems, it's not only like the software side of things that you gotta be worried about, but also the hardware side of things.
Mm-hmm.
So if you have an error, it could be a software error or a hardware error. And I remember when I first built my computer, I could, so when I first built it, it was working, and I could install Windows 10 on it. At the time, we didn't have Windows 11. So I could install like, the
Back
operating
in the day.
system. Yeah, back in the day. And it was working well for like a day or two. But then one day it just stopped working, and I had to both look at like the software side of things or the firmware and see if there's maybe like a bug in how I had installed the OS. And I also had to like take a look and like pull apart my computer and see if it's the hardware side of things that's actually like issues. But no, I think that can be like a good and bad thing.
Yeah, for sure. But it's definitely a good skill to have, like if you know how to deal with hardware versus like if you're just a coder, like and then something breaks, you're like, oh, time to take it to the repair shop. You know, like it's good to kind of have an understanding of both. But yeah.
No, for sure. But yeah, so let's move on to the next question. So where do you see embedded systems being most impactful in the next 5 to 10 years?
Ooh, wow, that's a really good question. From the kind of like research I've done, you know, I just kind of what we're seeing nowadays is a lot of AI stuff going on, you know, and I think AI is definitely going to start getting more integrated in kind of a lot of embedded systems, you know. I guess like also there's like, you know, self-driving cars and all that stuff, you know. You know, and you have some embedded system work in that. But I think definitely with AI, it's going to, you know, we're going to have to start making, you know, integrating those two things together. Sorry, could you repeat the question again? Was there like a specific? You know?
Oh no, I was just I just had like a general question about like in your opinion, like where do you think like embedded systems is gonna go?
Like it's gonna go
5 to 10 years.
Yeah, for sure. Yeah, no, I think it's definitely. Well, I think we're gonna have increased demand. You know, I think we've already seen a lot of increased demand.
Yeah.
If you take like smart home stuff for example, now pretty much almost everything in our houses have some sort of embedded system. You know, like our thermostats, our fridges, and like there's just so many things. And I think that'll definitely just keep increasing, and especially as we integrate AI into things, like it'll definitely pick up a lot. So.
No, yeah, it's interesting how you brought up just like home systems, because that's like one of the things that we also talk about in class. Just because so this is for my cybersecurity class, as you know. So we do talk a little bit about how like home like systems that like utilize embedded systems can be compromised. I'm not sure. Have you heard of like Ring cameras before?
I have, yeah. I've seen a few.
Ring cameras, or like have you heard like baby cams?
Yes, yeah, that type of thing.
So like I remember one of the things that we like talked about in class, one of my team was this one like this happened. I'm not sure where, but this happened like about a year ago. But so this one family, they had installed like a baby cam in their toddler's room. So, but then one day, they realized that they started hearing noises from the room, like from and like talking.
What the heck?
Yeah. So apparently that baby cam got hacked, and the hacker was like they had access to just like the camera, and also there's a video recording, and also they could they were like speaking on it and stuff.
Yeah.
So
that's wild.
So like with that in mind, how do you think cybersecurity principles apply to embedded system programming, and how can we implement those principles?
Yeah, no, that's a really good question, and it's something that I've actually kind of researching a little bit recently. You know, I don't have a huge cybersecurity background. I've learned a lot of the fundamentals and things like that, but I do recognize that in embedded systems, it's becoming especially more important now to you know learn how to apply cybersecurity principles to it. But yeah, we'll definitely need. It's the same with like self-driving cars. You know, that's like I think it overall like we'd have fewer like crashes on the road, but it's still scary to think like because it's like connected to the internet, like people could hack in, you know, and things like that. So when it comes to embedded systems, like we definitely need to have people to understand cybersecurity. especially, you know, and programming, and programming in general, you know, it's good to understand, but I think especially with things like that, like, you know, it's really important to have because embedded system stuff is literally everywhere, you know, like, yeah, like in like the kids room, you know, like it's pretty creepy, you know, like
Yeah.
trying to like hack in there, you know. But yeah, I think definitely something that we need to do, something we need to apply and make sure that like all the things that we're building should be tested and have people that understand cybersecurity better look at it, and also embedded systems engineers should understand it too, especially like, you know, the biggest like pitfalls and stuff. So yeah, I think there's a lot of focus put on it for sure. But.
I agree. I feel like when it comes to cybersecurity implementation,
Mm-hmm.
a lot of times with organizations, they tend to focus on just like the actual safeguard measures for when cybersecurity attacks happen. But I feel like it's way more important for you to teach everyone, like every single individual in said organization, or just every single individual who would use like these devices that would have embedded systems in them.
Mm-hmm.
I think it's more important to educate them on just really important or really essential like cybersecurity measures. So like simple things, you know, like for example, with like a laptop, like installing your antivirus, making sure that you keep it updated. So with the example of like a baby cam, maybe what they could have done is they could have like monitored it, making sure that that they updated it. Because I know some softwares like rim cameras, for example,
Mm-hmm.
you have to like manually update those, like because they do have like different softwares and updates. So I feel like just being on top of that is a really effective way of just maintaining cybersecurity.
Mm-hmm.
Just like yeah, it's so important. But I have one more question.
Yeah.
Okay, so the last question I have for you is, what advice would you give someone starting out in embedded systems programming?
Mm-hmm. Yeah, that's a really good question. Man, never thought of that before. Yeah. I think one of the most important things nowadays, when it comes to embedded systems and just like kind of software in general, you know, is just having a lot of experience, or not experience, but a lot of like your own experience. Like, for example, you should definitely like keep like, I don't know, I feel like a lot of people when they get out of college, like they might not have their own like projects and things, and like maybe they haven't like experimented around as much. One thing that I found that I need to do, you know, especially is just like having a lot of just like free time outside of class, not doing homework to work on projects. It's like with embedded systems, like if there's something cool you want to make, like make it, you know.
Okay.
Like don't just do it for a class, but like find time in the day to just do your own projects and your own programming. And I think during a couple semesters ago, I had this whole summer where I just like didn't program at all. And I came back and I was like, oh my gosh, I don't know anything. You know, like if I'd taken those 7 months to just like work on like personal projects and stuff, and just keep getting interested in learning new things, like there would have been so much benefit, I think. So I think just like my biggest advice for someone going into embedded systems or in computer science would be to take the time outside of class to make your own projects and to learn, especially starting early on, you know, because the higher up your classes get, it gets harder, you know, finding time for that, yeah. But looking back, like in my first few semesters, I'm like, oh yeah, I could have had so much time, I could have been working on projects or everything, you know. So yeah, even if it's just like, you know, just like half an hour every day, just like working on something else that's not involved in your class or your curriculum, or, you know, something outside of what you normally do, I think, so.
Okay. Yeah, no, I feel like that's very important. I think that's really important, just like in general, like especially with computer science.
Mm-hmm.
Classes are really important and stuff. Like projects that you work on during classes are like obviously there to help you. Right. At least for me, I found that I learn a lot more things when I like work on like projects that I myself like design, I myself like create, and also like put in like what the requirements are. So like just specifically just like trying to get that personal experience is very important. I agree with that.
Yeah, absolutely, and like totally like doing it with other people too is super good.
Yeah.
Yeah, like I was able to do the hackathon this last semester. It's super cool because like you just get to see how you work with other people and how like and we just worked on something that was like very unique, and I think we learned a lot of things too, like about like how APIs work and how you can integrate AI into your programs and stuff, and you know, it's just very, very good to like get some more like practical hands-on experience like that, and I think that'll help you just become a better programmer in general, and also better like easier to get a job too. You know, like if you just show up and you're like, I got a degree, like people will be like, okay. But if you're like, look at all these cool programs I'm making, or like all these like cool like projects I have, or if you like show them, you know, you can like show them some of your projects or show them videos of your projects, and then people, I think they're a lot more interested in that than just like someone who, you know, just has a degree, right? So
Yeah, totally. I think that's like another advantage of embedded systems, programming specifically, as opposed to just like software, just development. Because let's say if you do have an interview with like an employer, I think a really good way to like pique their interest would be to bring something like physical. So let's say if you created like a project that what was the project that you had created? You said?
Yeah, like the little like weather event
Yeah.
thing, yeah.
So like imagine how cool it would be to like actually bring that like in person into the interview and show them like a like real life demonstration of that. I feel like that would definitely like put you like way like above like
Yeah,
other
exactly.
candidates.
Yeah, no, for sure, because you can like talk about what you do all day, but like
Yeah, you
you
can talk
show
about it.
something.
Yeah, while you're showing it, which is pretty cool.
Yeah. Now, what I've been wanting to do for a while, to pique my interest, I thought it'd be really cool to like, you know, have you ever seen like Harry Potter or like Tom? Have you seen Harry Potter ever?
I've seen like the first
Yeah.
one. I think.
Do you ever like see like Tom Riddle's diary where like Ginny Weasley is like writing in the book?
Oh, yeah.
Back to him. I the other day I was in one of my classes and I was like, what if I like made that? Like, it's like with AI, like you totally could. And I thought like, you know, like you could literally just like get like some sort of like paperwhite board, you know, like Kindle Paperwhite type of technology.
Uh-huh.
You get that and then like write on it and have it like spit something out back at to you. Like ChatGPT could use like OCR like to read like your, or you could use OCR to like get your text, you know, and then like input it into ChatGPT and like have this little thing. I thought it'd just be like a really cool project, you know. And like I feel like if you just go for like fun projects like that, like to me that sounds like a really cool idea. I don't know how it sounds to everyone else, but like if you just get your own like cool ideas and create them and you show them to people, like the people you're getting a job interview for or something, you know, or you know whoever you're trying to work for, I think they'll see like that passion, you know, that you have, and it's just like really cool to like, it's a really good like sign for them, like, oh, this guy really likes what he does and he can like work on his own, and like I don't know, I think it's just good to work on like projects that are like you're passionate about, and just like it's good for resumes and for jobs, and it's good for you too, just like for experience. So
No, yeah, I agree. There's a lot of potential, like untapped potential still within like embedded systems. And I mean, like you can kind of see it with like the programming language that they use. Like C, you mentioned that it's been used for like 50 years now and it hasn't changed. So that means that it's still like really like useful and just helping people like innovate new ideas and stuff. But yeah, I definitely agree. But yeah, so the last part of this interview is I would like to show you like just a demonstration of like a program that I created for my programming with classes class. I think you took that last semester, right? Yeah, but I'm not sure if you remember. For one of the projects that we had to make, we had to create this one program where there's like different types of goals that you could set. It's so pretty much it's like you have a tracker, like a point tracker that you can use in order to keep you accountable for these goals. So I can just show you like a simple like demonstration.
Little demo of it.
But yeah, so this is what it is. So that's just like the main code and stuff. Oh wait, sorry, not this one. This one. Yeah, so we have specifically 3 different types of goals. So the first goal that we have is the eternal goals, and then we also have simple goals, and then we also have checklist goals. So pretty much how it works is with checklist goals, so it's pretty much you have to specifically set how many times you would like to complete this goal. So let's say, for example, you have a goal of practicing the viola, because I know you play the viola at least 5 times a day. On this program, you can specifically choose to the checklist goal type. Once you've chosen that, you can just put in the name of the goal and the description of that goal, and also how many times you would like to do it today. That's for a checklist goal. The other goal that we have is eternal goal, so like the name implies. So it's pretty much a goal that you would like to set, that you would like to do every day. So it's a goal that you would like to just do eternally.
Oh yeah, like constantly how life.
Yeah, so that one's also pretty simple. So you just have to put in that goal, and there's no like specific number of times that you have to do it. But it will keep giving you points as you track, or as you record how many times you've done it. And the next one is the simple goal. So simple goal, it's almost like the eternal goal, except that there's a specific number of times you gotta do to actually earn points. But yeah, if you just want to try it out.
Yeah, sure. You know, I actually never heard of this in my
really?
class. Yeah, so this would be kind of cool. So just click on
This,
just log it here.
and then click on here,
Okay.
and that should be develop file.
Develop 5 goal tracker. Okay. So we'll do a test run. Okay, cool. So you just like select one of these to like create a new goal, for example, probably the first likely thing to do. And so I could hit like 3 checklist. Name of the goal. How about it's a good checklist goal. I don't know. Different types of exercise maybe. Exercise. Description of goal. Okay. So I'd say like I want to exercise, or I guess the goal itself would be like to gain 5 pounds of muscle. There we go. Yes. 5 LES muscle points when complete. Ooh, okay. So you like specify the amount of points?
Yeah, so I forgot to mention that, but you can specify how much points you think you deserve as you complete the goal.
Okay, let's say 10. That sounds good. Just arbitrary number. Target count. Ooh.
Yeah, so for the checklist goal, like I mentioned, so there's like a specific number of goals that you would have to, or a specific number of times you would have to do that goal in order to actually receive those points.
Oh, I see.
Yeah.
Okay, let's do like 4 for 4 days a week maybe, or something like that. And bonus points completed 5. Cool. And then 2 with the list of goals, right? Oh, nice. Yeah. So
Yeah,
it's
so you
just
can see
like
it.
exercise completed 0 4, and then record event. We could do goal number. Was it 1? I assume. Or oh, there we go. Event recorded. Okay, cool. So now if we listen again, it would be like 1 out of 4. I got you. For show score, shows that we have 10 points. 5 goals, save goals. Oh, cool. I like that you actually like put a file name in. We'll call it exercise. And you have to put the extension TXT, right?
Yeah.
Okay. Cool. And then to load it, exercise.txt. Cool. Yeah, that's awesome. Looks like you deal with some file,
Yeah.
writing to files and reading files and stuff.
But no, yeah, like the reason I brought this up was like how it relates to cybersecurity. If you look at just like the main classes that I built for this, let's just use one of the classes for example. So this class is called Goal Manager. You can see that I implement principles of encapsulation. So I make sure that for attributes or variables that I do not need to be public are made private. So for example, we have a private attribute called score to keep track of your score as you go along this program. And you can see that it is private. So this means that if another person, let's say for example, let's say if I'm working in a team, let's say one of my team members, they would like to just make some changes to the code. Just make sure that, or just ensure that when they do make those changes, that the variables, the direct variables or the direct attributes will not be affected by like any like new code written. So they would have to like create like, let's say they do want to make changes to this, they would have to create like a separate method to get
Mhm.
that or to manipulate that within this class.
Like their external code won't change, like.
Yes.
That's what I mean.
Mhm. So the internal code won't change. If you do want to change like this variable specifically,
Mhm.
you would have to create like an external copy of it. If that makes sense.
Mhm. Yeah.
Yeah, but that, I feel like that really relates to cybersecurity because a lot of times cybersecurity like incidents or just like cyber attacks, they happen because of just like a simple line in the code that like went wrong.
Yeah.
So if you
like
have
leaving your
yeah.
password public, for example, instead of private.
Uh-huh.
That would be bad.
No, exactly. So when you have just safety, just principles in
Mhm.
mind when you're writing code like this, it
Mhm.
makes it a lot less likely to happen, in my opinion.
Yeah, no, definitely. That's a really good use of, a good example of, yeah, like how, like, yeah, if you did leave some, like, really important variables public, like, then it'd be so much easier.
Yeah, we always change it.
Yeah.
But no, do you have any feedback at all?
Yeah, I mean, I think the program seemed to work totally fine, you know, so I didn't really see any major issues. There might have been, like, one, like, a lot, like, I think it was, like, when I, like, loaded, or, I think when I listed it or something, like, it might be, I can see if I can run it again here. It was just, like, a spacing thing, you know?
Oh,
like,
okay.
like a little, like, line of blank space might have been nice
Oh.
to, like, organize better, but as far as functional, that's just a little nitpicky thing, but as far as functional things, it looks like it's working quite well, so, yeah, looks good to me.
Awesome, yeah. Well, thank you so much, Isaac. That's pretty much it for the interview.
Yeah, absolutely, no problem.
All right.
Thank you for having me. That was quite fun.